Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into a fascinating article detailing efficient implementations of hash tables and dynamic arrays in C. It's all about achieving speed and simplicity, even without the conveniences of C++.
Sounds exciting. I'm particularly interested in how they handle string manipulation in C, given its reputation for being tricky. What's the approach taken here?
Exactly. They cleverly sidestep the pitfalls of null-terminated strings by using counted strings. This significantly reduces the risk of buffer overflows and other common errors. They define a str struct with a pointer to the character data and its length. Ingenious, right?
I see. So how do they build the hash tables themselves? I'm curious about the performance implications of their choices.
They present two options, a flat hash map and a hierarchical hash map. A 4-anchory trie. The flat map is super simple. 2 arrays for keys and values, using double hashing for collision resolution. It's blazing fast for a limited number of keys, but it has a fixed size. The trie, on the other hand, scales much better, dynamically allocating nodes as needed.
So a trade-off between simplicity and scalability. What about memory management? How do they avoid memory leaks?
That's where the bump allocator comes in. It's a simple, efficient allocator that eliminates many memory-related issues. Allocation is done via a macro, new, which handles type checking and size calculations, preventing overflows. Deallocation is implicit, making memory management much easier. Very clever.
That's a neat solution. But what about dynamic arrays? How do they mimic std vector in C?
They use a slice structure, containing pointers to the data, length, and capacity. A push macro handles adding elements, dynamically expanding the underlying array when necessary. It's a bit more involved than the hash tables, but still remarkably concise. The implementation cleverly reuses memory when possible, avoiding unnecessary copies.
And how do they put it all together to create an envp array for exechev?
For the flat hash map, it's straightforward. They iterate through the key-value pairs, concatenating them into strings suitable for envp. For the trie, they use a recursive approach initially, but then they cleverly switch to an iterative solution using a stack to avoid stack overflow issues with large environments. They even incorporate a small size optimization for the stack to minimize memory usage.
That's impressive. Did they address any security concerns related to hash tables?
Yes. They introduce a technique called hash hardening to mitigate attacks that exploit hash collisions. They use ASLR, address space layout randomization, to seed the hash function, making it much harder for attackers to predict collisions and cause worst-case performance.
That's a really insightful addition. So overall, this article demonstrates that you can achieve high performance and efficiency in C, even with complex data structures, right? It's all about choosing the right primitives and techniques.
Absolutely. The article showcases how careful design and efficient algorithms can compensate for the lack of built-in features like templates and smart pointers in C. It's a testament to the power of low-level programming when done well. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll see you next time.
Bye-bye.